Okay guys, so I'm going to go over the lesson for today. So this problem, we're given a unit conversion. There's 1 mole. In 1 mole, there are 6.022 times 10 to the 23rd molecules. And that is a conversion factor. And we're going to use that to help us solve this problem of how many molecules are there in 5.0 grams of calcium chloride. So the first thing that we can do is draw a path. And that can help us to see what to do when we're stuck. So what we're going to do with that is we're going to start with what we're given. We're given grams. And our final thing we want to get to is molecules. So we're going to write molecules here. Note that molecules is different than moles. I know they start with the same couple letters, but they are different. And so we don't know a way to get directly from grams to molecules. So that means we need to have some steps in the middle. And we're given that 1 mole, there is 6.022 times 10 to the 23rd, or Avogadro's number, if you remember from our mole lesson. So we can convert molecules if we have the number of moles. And then from our last lesson, we learned how to go from grams to moles and moles to grams. So we're actually doing 2 different steps. First, we're going to convert from grams to moles, and then from moles to molecules. So this can kind of help us space out what we're doing. So now we're going to solve our problem. So we're starting with 5.0 grams. So we're going to go ahead and write that of calcium chloride. And because our first step is to take these grams and go to moles, that means we want our grams to cancel. So grams are going to go on the bottom, and we're going to first turn them into moles. And if you remember from our last lesson, when we're going from grams to moles or moles to grams, we have to use the molar mass because the molar mass is going to be different depending on the compound that we're using. So we're just going to add them up. And let me pull up my calculator. So for calcium, there's only 1 calcium, and its mass is 40.08. So we're going to add that. And then there are 2 chlorine atoms. So we're going to use 2 times our chlorine mass, which is 35.45, and we're getting these masses from the periodic table. So we know that our total mass is 110.98. And the unit for this is grams per mole. So, and if you remember, because this is grams, another way to think about this is 110.98 grams per 1 mole. We can go ahead and put this number with our grams down here. And then 1 mole. So now our grams cancel and we're left with moles. So now we can go ahead and do our next step where we're taking our moles and we're converting it into molecules. So we want our moles to cancel, so now we need to put moles. We need to put moles on the bottom. And what's nice when we're going from moles to molecules is that the conversion factor is the same every single time. It's always going to be the 6.022. It doesn't change like our molar mass does based on the compound. So we know in 1 mole, so we're going to go ahead and put our numbers. 1 mole, there's 6.022 times 10 to the 23rd molecules. So that number is going to go here. So now our moles can cancel and we're left with molecules. So now we just need to put this in our calculator. So remember, we multiply everything on top and divide everything on bottom. So we're going to do 5.0 times our 1. You can skip the times 1 if you would like. Times our 6.022 times 10 to the 23rd. Okay, divided by our number down here, 110.98. And if you would like to do divided by 1 as well, you can. And we get a very large number because we are talking about molecules. So it makes sense that we have a very huge number. But we don't really want to write out the number this way, so you're going to need to use scientific notation. Usually you can just convert it in your calculator, or you can figure out what the answer is. But we need to write it according to sig figs. So we're starting with 2 significant figures because both the 5 and the 0 here are significant because there's a decimal that makes the 0 significant. So our answer will also have 2. So we'll have the 2 and the 7 that are significant. But we also need to remember to include our times 10 to the 22nd in this case. And this is molecules. Okay, so that's how you solve one of these problems. You just have 2 steps. Here's another example. You can pause the video and try it on your own if you would like. Okay, in this one, we're starting with 4.5 grams. First, we need to convert our grams into moles because we're going to eventually get to molecules. To do that, we need the molar mass of CH4, which is going to be 12.01 plus, I'm going to take this out of, plus 4 times our mass of hydrogen. So it's 16.05 grams per mole. This number goes with our grams per 1 mole. Our grams cancel. So now moles, we're going from moles to molecules. In 1 mole, there's 6.022 times 10 to the 23rd molecules. So now we're left with molecules. We can put this in our calculator. And we have 2 sig figs because 4.5, so we're going to write 1.7 times 10 to the 23rd molecules. That's our answer. Okay, if you'd like to try one more, I guess I have a couple more. Okay, so this one we're going to do 55.1 grams of CO2. We need our molar mass of CO2. So 12.01 is carbon, plus we have 2 oxygen. So our mass is 44.01 grams per mole. So this number will go down here per 1 mole. Our grams cancel. We have 1 mole in 6.022 times 10 to the 23rd molecules. Our moles cancel. We'll put this in our calculator. And this time we have 3 significant figures. So we're going to write 7.54 times 10 to the 23rd. Molecules. Okay, so that's how we get from grams to molecules. And now we can even go the other way. We can be given the number of atoms or molecules and go to grams. So this time we're basically going the opposite direction. So in this one, we will start with 3.7 times 10 to the 24th atoms, which is the same as our molecules in this case, because 1 atom makes up a molecule of sodium. So that means we want our atoms to go on the bottom, and we're going to convert it into moles first. Just like before, we're just going backwards. So in 1 mole, there's 6.022 times 10 to the 23rd atoms. Those atoms can cancel. And then we want to convert our moles into grams. To do that, we need our molar mass. We can look up the molar mass of sodium is 22.99 grams per mole. So we're going to put that number up here. So now our moles cancel and we're left with grams. So this time we're going to do 3.7. Let me put that in parentheses. Times 10 to the 24th. And then we can multiply by our 22.99. And then divide by our Avogadro's number. Oops. Let me try that again. Okay, and we're only going to use 2 sig figs, so we will round this to 140 grams. That's a 0. Okay, so you can try this next one on your own. Okay, so this one we're given atoms. We're going to start with 9.56 times 10 to the 23rd atoms. We're going to convert atoms to moles. We know there's 6.022 times 10 to the 23rd atoms in 1 mole. We need to now convert moles into grams. We need our mass of our chlorine. So chlorine, there are 2 because chlorine is a diatomic element, and our mass of 1 chlorine is 35.45. So that means our total mass is 70.9 grams per mole. So our atoms cancel, our moles cancel, we're left with grams. So we're doing 9.56 times 10 to the 23rd atoms times our molar mass, which is 70.9, divided by Avogadro's number. So we have 3 sig figs, so we're going to round this 2 to a 3, so we're going to write 113 grams. That's how you solve these problems. We can also do a similar type of conversion with liters. So we're going to start this by drawing our path again, because I can tell you that 1 mole of gas takes up 22.4 liters. This is something that's only going to happen at STP, which stands for standard temperature and pressure, which is 0 degrees Celsius and 1 atm. You don't quite have to worry about this yet. We'll get to this when we talk about gas laws later in the year. So we're going to draw our path again. So this time we are starting with grams, and we want to get to liters, but we can't just go straight from grams straight to liters. We need to first convert to moles, because that's the unit conversion factor that we have. So now we can go ahead and solve our problem. So we're starting with our grams, so we have 5.0 grams. We can now convert grams to moles, so we're going to put grams and then moles up here. We need the mass of calcium chloride, which I think I did earlier, but we can go ahead and do it right here. Calcium's mass is 40.08, plus there are 2 chlorines, and chlorine's mass is 35.45. So 110.98. And that's grams per mole, so we're going to put that with our grams down here. Now we're in moles, and we're going to convert our moles to liters so that our moles can cancel. And we're given here that in 1 mole, so we're going to put 1 with our mole, a gas takes up 22.4 liters, so 22.4 liters goes here. So now we're left with liters. So we just have to multiply and divide. So we're going to do 5.0 times 22.4 liters divided by 110.98. We have 2 sig figs here, so we're going to also write 2 sig figs. So this will be 1.0 liters. So these work very similarly to our atom and molecule conversions. So you can try this one. So this one we're starting with 4.65 grams. We're going to convert our grams first to moles. We need the mass of our N2, which is 14.01 times 2, so 28.02 grams per mole. Our grams cancel. Our moles we're going to turn into liters. We know that in 1 mole is 22.4. Oops. Let's redo that. So now our moles can cancel. We're left with liters. We're going to do 4.65 times our 22.4 divided by 28.02. And we have 3 sig figs this time, so we're going to round this to 3.72 liters. Okay, so you can try this one. We have 5.463 grams. We're going to go from our grams to our moles. We need the molar mass of CO2. So we have 12.01 plus our 2 times our oxygen, which is 16. So 44 grams per 1 mole. So now we're going to convert our moles to liters. We have 22.4 liters in 1 mole. We can plug this in our calculator. And this time we have 1, 2, 3, 4 sig figs. So we're going to write 2.781. And then our unit, which is liters. Okay, we can also go the opposite direction when we're given liters. We can figure out grams. So you can pause the video and try this one on your own. But this one we're going to start with 5.0 liters. We first need to turn our liters, just like before if we're going backwards, we need to turn our liters into moles. So we know that in 1 mole there is 22.4 liters of gas at STP. So now our liters cancel, we're left with moles. We want to cancel those moles and turn them into grams. So we need the molar mass of oxygen. Oxygen's mass is 16.00. Oops, I don't know what I did there. Times 2 of them, which is 32 grams per mole. So that 32 is going to go with our grams. So now our moles cancel. So we do 5.0 times 32 divided by 22.4. We have 2 sig figs. So we're going to write 7.1 grams. Oops. And we can try one more. You can pause the video and try this one. 45.2 liters. We're going to go from our liters to moles. 1 mole has 22.4 liters in it, but our liters can cancel. Our moles we can turn into grams so that our moles cancel. We just need the molar mass of CH4, which is 12.01 plus 4 times 1.04, 16.05 grams per mole. So that goes with our grams per 1 mole. And then we can put this on our calculator. And we have 3 sig figs, so we'll write 32.4 grams. Okay, so that's how these work. You can also think of this as you need to always convert to our moles. So this is a visual graphic that can help you. If we're in atoms, we need to go to mole island, I guess, first before we can get to grams or before we can get to liters. So you can always convert these things because we know what the unit conversions are. So you can fill in then what you're doing for each of them. And if you notice, if we're going from atoms or molecules to moles, we're dividing by Avogadro's number. And same with if we're going from grams to moles, we are dividing by the molar mass. If we're going from liters to moles, we're dividing by 22.4. So anytime we're going to a mole, we're dividing. Anytime we're given mole, we're multiplying. So this could be another thing that you use to remember that moles, if you're given moles, you're multiplying. So M for mole and M for multiply. Depends on what you're multiplying by, depends on where you're going. So if you're going to grams, you multiply by molar mass. If you're going to atoms or molecules, you're multiplying by Avogadro's number, 6.022 times 10 to the 23rd. And if you're going to liters, you're multiplying by 22.4 liters. So this can kind of help you understand how it's going to work. Okay, so this is the ticket out the door. If you missed class, you can turn it in.